All right, for today's lesson, we're going to be looking at pairs of angles. I should note before we get started on this that this material will not be on our first test. Our first test is next Tuesday. This will not be on that test. This will be on the test after that. This is going to happen pretty regularly in this class where because of our constraints of test days, and other calendar considerations that will be going on into the next unit before we have tested on our current unit. So here we're going to be talking about pairs of angles. And before we jump into that, I want to talk to you about an idea that is going to come up here. Let's say that this is a table. Let's say that it's in the cafeteria and you are sitting here. And you have a friend sitting here and a friend sitting here. The term for that, when they are sitting next to you by your side, is adjacent. Adjacent, just in general terminology, means that they are next to you. As opposed to if you had a friend who was sitting over here, that would be opposite. They're on the other side of the table. So adjacent means next to, side by side. Well, that's the idea behind this next term for geometry, adjacent angles. Adjacent angles are two angles with a common side and a common vertex and a common side, but no common interior points. So let me show you how that would look. So here we have that angle RST, this angle, and angle TSV are adjacent to one another. They have to have a common vertex. We can see that just by this. S is the vertex. Notice I can also identify, well, one side of this is ST, the other side is SV. For this one, I have a side that's ST, and this one, the other side, is SR. They share a side. They share ST. Both of them have that same ray in them. So that's two of the qualifications, and then the other qualification is that if you have a point inside of the first one, it can't be inside of the second one, and vice versa. If I have a point inside the second angle, it cannot be inside the first one. And that's why this next pair of angles are not adjacent. Angle RST and angle RSV. Notice they both have the same vertex, S. They both have side SR in them. They share that side, but let's look. Angle RST, that's this angle. So I put a point, inside the interior that. Is that inside angle RSV also? Yes, it is. That's why RST and RSV are not adjacent, because although they have the same vertex and they share side SR, they share interior points. More colloquial speaking, we could say that they overlap. Here's RST, and I'll shade in its interior, and then in another color, let's do black. Here's RSV, and I'll shade in its interior. See how the two interiors overlap? Adjacent means next to. So like in our example from the cafeteria, your friends are sitting next to you, not sitting in your lap. They are adjacent to you, not overlapping one another. Okay? All right, so let's look at some other ones. Here, angle 1 and angle 2 are adjacent. They share this vertex. They share this side. They don't overlap each other. Angle 2 and 3 are adjacent. Here are angles 2 and 3. They share this vertex. They share this side. 2 and 3 don't overlap each other. That's adjacent. On the other hand, 1 and 3 are not adjacent. Angles 1 and 3 share a vertex, but they don't share a side. Here are the two sides for angle 1. Here are the two sides for angle 3. They don't share a side, so they are not adjacent to one another. So a type of angles that we're going to do for the rest of the year, I promise you, in the very last unit of the year, we will talk about these some more. So you need to learn the term now. At the end of the year, I will remind you when we get to this. I'll say, I told you the first month of the year that we're going to do these all year, and I didn't lie to you. A linear pair of angles. A linear pair of angles are two adjacent angles whose non-common sides are opposite rays. So they have to be adjacent to one another. That's the first qualification. Got to be adjacent. In order to be adjacent, they have to have the same vertex, and they have to share a side, but they cannot overlap one another. 1 and 2 don't overlap. And then their non-common sides, the other two sides, one from each of them, here and here, are opposite rays. Or you could just say they make a line. That's where they got linear pairs from. Linear pairs always are stuck together. That's the adjacent part, and they make a line. All right, some terms that you learned back in junior high. Just to remind you, complementary angles are two angles whose measures have a sum of 90 degrees. Supplementary angles are two angles whose measures have a sum of 180 degrees. Now, I always tell students, don't cut off the definition. Complementary does not mean 90. It means two angles whose measures have a sum. In other words, we add them together and we get 90. If you just say complementary angles are 90, that makes it sound like they're right angles, and that's not true. Supplementary angles, same idea. Two angles whose measures have a sum of 180 degrees. So if we look at this, angle A and angle B are complementary. How do I know that? Well, I know they're complementary because 32 plus 58 is equal to 90. Which two are supplementary? Well, let's see. If I add 32 and 122, that's 154. That's not it. How about if I add the 58 and the 122? That's 180. So angle B and angle C. Those are supplementary angles. So we're going to go a little deeper, though, than you went in junior high. And that's this idea. The measure of the complement of an angle is 90 minus the measure of an angle. And the measure of the supplement of an angle is 180 minus the measure of the angle. So if I am a 50-degree angle, my complement is 40 because that's what it takes to add to that angle to get 90. And again, if I'm a 50-degree angle, my supplement would have to be a 130-degree angle so that when we add those two together, we get 180 degrees. Why is that important? Well, it can help you do all kinds of problems. Let's look at some examples. So find the measure of the complement of a 68-degree angle. Well, the complement, just by what we've written up here, is just going to be 90 minus 68. So that's 22 degrees. For this next one, there's going to be one like this on your homework tonight, and I promise you there will be one like this on your quiz on this, and some of you will forget it, and some of you will miss it because of that. It's not a hard problem, but it feels a little strange. So you might want to put a big star by this. that be sure to study this before the quiz on the next unit. Find the measure of the supplement of an angle whose measure is 3x minus 17. Well, again, the supplement, let's try that again. The measure of the supplement of the angle is equal to 180 minus the measure of that angle. Not 117, just 17. And all we're going to do here is simplify this. So that's going to be 180 minus 3x minus the negative 17 is plus 17. So it's 197 minus 3x degrees. And that is the best that we can do here. We cannot do anything else on this problem. And that feels a little strange. You're like, I'd like to be able to solve for x. You cannot solve for x for this one. There's no way of knowing what x is. Okay, again, promise you, there'll be one like that on the homework. There will be one like that on the quiz. And some of you, unfortunately, will likely miss it because you will have forgotten this by then. Now, this idea can also help us when we're doing word problems. So take this one, for example. An angle's measure is 3 less than twice the measure of its supplement. Find the measure of the supplement. Well, when you're doing a word problem like this, the word is actually a shortened version of is equal to. So you could have read this as an angle's measure is equal to 3 degrees less than twice the measure of its supplement. So when we find the word is in a word problem like this, it's equal. So everything before has to be written as an expression, and everything afterwards has to be written as an expression. So we're going to write an expression for an angle's measure. The simplest thing to do for that is just to call it A. The angle's measure is equal to. And then all of this has to be put together and written as one expression. Not one letter, but one expression. 3 degrees less, that means we're going to subtract 3. From what? Twice the measure of the supplement. Okay, so I need to multiply 2 times the supplement. Let's call the supplement S for right now. So this would be a simple way of rewriting this. Now, there are 2 different ways to solve this problem from here. We've rewritten this, but the problem that I have right now is there are 2 variables and, well, only one equation. That's a problem. What you can do is, first, we know the supplement of an angle is 180 minus the angle. The measure of the angle is A, so we can go A equals 2 times, and I'm going to replace the supplement with 180 minus A. And again, that's why you don't want to think the supplement is 180. The supplement is the angle that you have to add together to get 180 minus 3. Distribute the 2. We get A is equal to 360 minus 2A minus 3. Add the 2A to the other side, and we've got 3A equals 360 minus 3 is 357. Divide by 3. The angle is 119 degrees. And then the supplement is 180 minus A, so 180 minus 119 is 61 degrees. That is one way you can solve this. The other way you can solve this involves writing a new equation. And that new equation is that you know that an angle added to his supplement is equal to 180 degrees. Now I've got two unknowns and two equations, and I can substitute this in the place of A because it's equal to A. So that would be 2s minus 3 plus s is equal to 180. Grouping the like terms, that's 3s minus 3 is 180. Add 3, we've got 3s is 183. Divide by 3, and s is equal to 61. So it doesn't matter which one of those you choose to use. They both take about the same amount of time. If it's asking at the end for the angle, I tend to do the first one because it finds the angle. If it's asking for the supplement, I tend to do the second one. But you can do them all the same way. If they were asking for the angle on this, you would know that the angle is 2 times the supplement minus 3. So you could substitute back into this equation and solve for A. All right. Another new term today, and again, this is one we will use all year long. At the very end of the year, we will still be using vertical angles. So, what are vertical angles? They're two non-adjacent angles, so they're not right next to each other, formed by two intersecting lines. In fact, we could say that they were two opposite angles formed by intersecting lines. So in this picture, 1 and 3 are vertical angles, here and here. 2 and 4 are vertical angles. They are opposite each other. They're across from each other. Just as a reminder, what kind of angles are angles 2 and 3? Well, 2 and 3 are adjacent because they share this side and they don't overlap. And their other two sides, so this is the one that they share, their other two sides make a line or make opposite rays. So those are a linear pair. They're a pair of angles that together make a line with their non-common sides. All right, that is it for today's lesson. Hopefully I will see you on Friday, and I wish you good luck on your quiz today.